Good afternoon, everyone, dear authors and invited guests. It's my great pleasure to welcome you to the ICICT International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Research Foundation. As every one of us is passing through these unforeseen circumstances, we wish everyone and their families a safe time. With immense happiness, I'd like to share that we have received an overwhelming response this year from over 90 different countries, where over 1,000 papers were received and 350 papers were accepted, contributing to the success of this conference, which will be published in 4 volumes this year. We are thankful to our guests present on this platform to join us digitally for this conference in these unpredictable times. I would like to introduce to our session our chair, Valentina Emilia Ballas. Valentina? She is currently a full professor at the Department of Automatics and Applied Software at the Faculty of Engineering, University of Arad, Romania. She holds a PhD in Applied Electronics and Telecommunications from Polytechnic University of Timisoara. Dr. Ballas is an author of more than 270 research papers in referred journals and international conferences. Her research interests are in intelligent systems, fuzzy control, soft computing, smart sensors, information fusion, modeling and simulation. She is the editor-in-chief to International Journal of Advanced Intelligence Paradigms and to the International Journal of Computational Systems of Engineering. Dr. Ballas is the director of Intelligent Systems Research Center in University of Arad and director of the Department of International Relations, Programs and Research in the same university. Dr. Emilia, welcome to the session.
Thank you very much. Thank you for the presentation. I can see the authors are here, and I congratulate you all for sending so nice papers to the 6th International Congress on Information and Communication Technology. We will start soon our track, and the first paper, it's here, I can see. It's applicability on AutoML to modeling of time series data. So the presenter is here. Please, you have the word. Before starting, you know the rules, 15 minutes, but 12 minutes for presentation and 3 minutes for some questions. So you can start, please.
Ajanta, are you here?
So Ajanta, it's here.
I don't think she's here, so let's move on to the next presenter.
Yes, maybe she will log in after that.
Later, yeah.
Yes, the second paper is COVID-19 related communication on Twitter, analysis of the Croatian and Polish attitudes. And presenter Carlo Babic.
Yes, hi, thank you.
Yes.
So I should share the presentation.
Share the screen, yeah.
Yes.
Presentation.
You can see it?
Yeah.
Perfect. So hi, I'm Carlo. And this is the beginning of the research we are working on in our project InfoCode. Okay, so the title was presented already, COVID-19 related communication on Twitter, analysis of the Croatian and Polish attitudes or sentiment. After the introduction, I will describe the data sets, then I will show you the results of our analysis, and I will end with a conclusion and future work plans. As we are currently still working on the project, this is just the introduction to the project, let's say it like that. So this work has been supported by COSTNET and Infocub, which is funded by the Croatian Science Foundation. Social media accelerates information spreading and may cause an infodemic, especially during a crisis. We can see that very much so currently. Automatic classification of positive, neutral, and negative attitudes in social media and automatic detection and prediction of fake news spreading play an important role and may improve various aspects of crisis communication. In this paper, we compare Polish and Croatian discourse about COVID-19 on Twitter in the first wave of COVID-19, so the first 7 months or so. First, we collect COVID-19 related tweets in the Croatian and Polish language and perform automatic annotation of tweets using sentiment lexicons and a classifier. Next, we analyze the distribution of positive and negative tweets over time. And after that, we analyze the most frequent tokens in positive and negative tweets. After we filter the tweets that are COVID-19 related, almost 4,000 Croatian and 1 million Polish tweets remain. Currently, we have more, but at that time, that was the number. The annotation method we use follows two main steps: automatic annotation and trained annotation. Automatic annotation uses a sentiment lexicon to score each tweet by calculating the number of positive words minus the number of negative words in a tweet. We configured the annotator to be strict, which leads to a low number of negative and positive tweets, which is actually a good thing because tweets annotated as negative or positive are very likely in the right class, and all the tweets for which the automatic annotator is uncertain, which is a majority in this case, are annotated as neutral. After the automatic annotation comes trained annotation. So trained annotation is an iterative process of training our classifier. It has 4 steps in our case. In the first step, the classifier is trained on the annotated data produced by the automatic annotator described in the slide before this one. In the second step, after the initial training, that model that was trained classifies the neutral tweets as they were annotated by the automatic annotator into positive, negative, and neutral. In the third step, after this one, the total number of positive and negative tweets is higher, and the number of neutral tweets is lower. And the classifier is trained again on the newly annotated data. In the last fourth step, all the tweets are again annotated by the retrained model, and with that we have the final annotated data sets we are working after that. For trained annotation, we vectorize the data by using a bag of words approach, where singular words and word pairs are used as units. We use naive Bayes for our classification model. Meanwhile, in the current work, we switch to fast text embeddings and a feed-forward neural network for classification. And in the future work, we plan to use BERT embeddings, which we are currently trying to figure out how to run on our server. So this is a second. After the dataset has been annotated, this is the percentage of negative, neutral, and positive tweets in the Croatian and Polish dataset. But this is less important as we normalize those classes for analysis, because we are interested in the change of sentiment over time and less so in the absolute sentiment, because that's by itself isn't really correct. But the change of sentiments over time, as you will see, can give us some explanation for some of the timeline. We analyzed the number of COVID-19 related tweets per day and sentiment over time by using mean values and the normalized ratio of positive and negative tweets, which I will show. And we show the most frequent COVID-19 related tokens that appear in positive and negative tweets. So the first analysis. The first peak in the number of tweets about COVID-19 happened at the same time in Croatia and Poland. So yeah, this is a plot of the number of tweets each day through the time of the first wave. So this is the first peak, and it correlates with the first cases when the first cases were reported in the countries. That's February 25th. The biggest peak happened first in Poland. That's the red plot. On March 11th, while in Croatia, the peak on that day was relatively smaller, over here. And it reached the highest point 10 days later than the Polish tweets, over here. The number of tweets about COVID-19 gradually got smaller, both in Croatia and Poland, until June 19th, when in Croatia the number of COVID-19 related tweets begins to climb again, because at that time new wave was actually incoming. So yeah, all the mentioned peaks correlate with the COVID-19 infection waves. So to analyze sentiment trend over time, we first set the values for negative, neutral, and positive sentiment to -1, 0, and 1. With those values, it is easier to calculate and visualize sentiment's behavior through time by using different methods. Here we plotted the mean sentiment value with a 7-day sliding window. Both in Croatia and Poland, sentiment was at first at its lowest at the beginning, after which it begins to climb until March 6th, where it somewhat stabilizes, relatively speaking. The beginning especially, and the end of the visualization is noisy because we have less data for those time periods, especially for Croatia. A Polish dataset has more data. I like this plot the best. This figure plots the ratio between the normalized number of positive and negative tweets. So it's a ratio between positive sentiment and negative. It is normalized, so the difference in the number of tweets between the two datasets doesn't have an effect on the visualization, because the Polish dataset has a lot more tweets. So on day 33, we can see a positive peak, especially in Croatia, the blue line, which correlates with the first COVID-19 cases. But it seems that people are ironic and in denial, because as you can see, the peak is positive, which means it's a positive sentiment. On day 41, the Croatians begin to realize that COVID-19 is a serious threat, and events started to cancel, like concerts and so on. Hence the negative sentiment. Approximately at the same time, Poland detects the first cases as well. A negative peak on day 57 correlates with the worst day in Italy so far. And at the same time period, in Croatia, the number of infections rises and a destructive earthquake hits the capital, which is as well visible here in sentiment trends in Croatian dataset. While the positive peaks on days 50 and 62 correspond to support between internet users, because after each of those negative peaks, people started to support each other on Twitter and say nice things. Negative peaks in this region correspond to self-isolation, government closing the borders, and isolation at the time of Easter. The positive peak on day 103 is probably due borders being opened in Poland and almost no new cases in Croatia. We can see a negative peak on day 115 at the time of Croatian parliamentary election and Polish presidential election campaigns. When people start talking about politics, the sentiment always goes down. And at the end of the data set, the sentiment was down because the new wave was incoming, which is visible. Next slide. Here we ordered all the tokens by their frequency of occurrence in positive and negative tweets. In the second column over here, you can see the ratios between those two frequencies, which are first normalized with relation to the total number of positive and negative tweets. In Croatia, tweets directly mentioning COVID-19 or the pandemic are mostly negative. Political tweets are also negative as well, and tweets mentioning measures such as quarantine and masks are mostly positive. In Poland, negative tweets are frequently associated with reporting cases, deficiency in the healthcare system, economic crisis, or elections. Positive tweets are frequently associated with anti-crisis, social mobilization, and support. And to conclude, the interest in the COVID-19 topic on Twitter in Europe is primarily of a social, not medical dimension, which doesn't surprise us. And the peaks of interest and changes in sentiment are mainly driven by social or political issues. Sentiment analysis revealed positive attitudes during stay-at-home consolidation and the support phase during the second part of March, and negative attitudes during political campaigns and late June. In future work, we plan to expand the datasets by using a longer range of dates as some time has passed, and by training a classifier that can filter more precisely tweets related to COVID-19. Comparison of sentiment trends for COVID-19 related tweets. Wait a second. Yeah, we plan to do a comparison of sentiment trends for COVID-19 related tweets and tweets that are not related to COVID-19. And further, we can examine semantic content by analyzing the distribution of topics through time. Thank you for your attention. Any questions?
Thank you very much for the presentation. Let's see if there are questions. If no, some remarks from my side. I consider very interesting your paper, and maybe you are, I can see here you are a team from Croatia and from Poland, and you put together all this information and made a nice comparison between these two countries. It is true that negative tweets are always the same in this period. We saw some delays between peaks in Poland and in Croatia, and it's normal like this. Many of them are related to COVID and to elections and to other certain things. It is good that you propose for the future to continue and to do sentiment analysis, and maybe it's good that your politicians to see all these peaks and to try to do something for people in their countries. So once again, thank you very much.
Thank you.
Questions, if there are more? No. We will go further to the next paper, Anomaly Detection Survey. Presenter Tahani Hussein Abu Musa. It's here.
Yeah, present.
Yes.
I'll share the screen in a moment.
Yes, please share the screen.
Sure. Okay. So good afternoon and good evening, everyone. My name is Tahani Abu Musa. I'm a computer science PhD student at Qatar University. I'm also an information technology lecturer in the Community College of Qatar. I'm here to present my current findings as a survey paper on anomaly detection, and this is the application domain that I'm currently working in my study. As an acknowledgement, this research was achieved as part of the National Priority Research Program, NPRP, project funded by the Qatar National Research Fund. The topic of our project is Supply Ledger Project, designing an efficient smart contract-based blockchain system for multi-model supply chain systems. The outline of my presentation will be as follows. First of all, we'll go into an introduction about the anomaly detection domain and possible applications exist in literature. And then we will define what is an anomaly, types of anomalies that we are interested in, modes, techniques, and output of anomaly detection. And then I will have a brief about the application I'm currently working in my study. And finally, some concluding remarks of our work. To start with, anomaly detection is considered one of the important research areas nowadays and can be used across a vast number of application domains. Those application domains are included but not limited to intrusion detection, fraud detection, industrial damage detection, anomaly detection in image, public health and medical anomaly detection, and finally, supply chain workflow anomaly detection. And this is the area of interest, and this is the domain that I'm working on currently in my studies. Now we would like to define what an anomaly is. The first definition was given by Grubbs back in 1969. An anomaly, or an outlying observation or outlier for short, is the one that appears to deviate markedly from other members of the sample in which it occurs. And when we define the field of anomaly detection, we refer to the process of discovering uncommon or unpredicted items or behaviors in the dataset. Now, in the literature, we do have three main types of anomalies: point anomalies, contextual anomalies, and finally, collective anomalies. When we talk about point anomalies, we refer that a single point anomaly that deviates from the entire distribution of the dataset. Contextual anomalies, we talk about an anomaly that it's discovered within a certain or a given context. When we talk about collective anomalies, we have a number or a series or a collection of anomalies that are considered anomalous as a set or a collection across the entire data set. Now, when we talk about the modes, every anomaly detection techniques works in one of the three main modes. The first one is called supervised anomaly detection, and as the name implies, it relies on the presence of labeled data in the training phase, so that the labels existing are for both the normal and anomalous class. The second mode is the semi-supervised anomaly detection, in which the techniques of this mode use training data set that only has data labels for the normal class, whereas the labels for the anomalous class are not required. When we talk about the unsupervised anomaly detection, this mode doesn't entail the presence of labeled data at all. Instead, it assigns scores for data points, and based on that score, will be discovering whether this data point is anomalous or not, based on the intrinsic properties like densities or distances. When we talk about the techniques exist in literature, there are four main categories of anomaly detection techniques. The first one is classification-based, and as the name implies, it depends on classifying the data points to the normal class or anomalous class. It falls under two subcategories, like the one-class classification and multi-class classification. Algorithms included in this technique are called neural networks, Bayesian-based networks, and also rule-based algorithms. The second category is the nearest neighbor-based techniques that use either similarity measures or distance defined between the data points. The two algorithms that fall under this category is the distance to the kth nearest neighbor and the relative density anomaly detection technique. The third technique is called the clustering-based techniques, and as the name implies, it relies on the fact of clustering data sets into clusters or sections, and any data point that doesn't belong to any of these clusters will be considered anomalous. We have three well-known algorithms fall under this category: the find-out algorithm, the cluster-based local outlier factor, and finally the self-organizing maps. The fourth category is the statistical-based techniques that relies heavily in building a statistical model of our entire data set, and then performing some statistical analysis actually to judge if this data is anomalous or not. We do have two subcategories of this technique. That is called parametric, in which the distribution of the data set is already known, like Gaussian distribution or regression-based distribution. And the non-parametric, the distribution of data is not known, but inferred from the data set itself. Now, when we talk about the output of any of the previously mentioned technique, it's either labels, like we do in the classification-based. So the labels will be used for classifying that data point across the testing database, whether it's a normal or anomalous data points. And also the scores, that the techniques that use this output, actually, they assign a score to every instance in the entire data set, as explained previously, depending on the level of which a certain instance is declared anomalous. Since the output would be a ranked set of anomalies, this ranked set of anomalies, we may consider the top ranked ones for further analysis, or also we can assign a threshold value and compare each data point against that threshold to judge or to declare it anomalous or not. So that was a brief introduction about the application domain, or actually the anomaly detection domain. Now I would like to get you a brief of what I'm currently doing in my study. My application is about anomaly detection in blockchain-enabled supply chain with a deep learning flavor. So in our context, in the business processes context, more specifically in the supply chain context, we define anomalies as a deviation from a predefined behavior, which is the predefined business process model, the normal flow of our business processes. Anomalous events in this case are those events that do not actually occur within the predefined sequence of events in that model. Now, this is the aim of our work, actually. Our work aims at the following: to propose an anomaly detection framework for detecting anomalous transaction in business processes. Those business processes are discovered from the transaction event logs. Those event logs are obtained from the supply chain management system, namely the ERP system in our case. Such framework will help us enhance the accuracy of anomaly detection in the global supply chain, improve the multi-level business processes workflow, and also will optimize the processes in supply chain in terms of security and automation. Now, as an example of a normal workflow, we have the procurement process scenario. These are the series of events that appear in a certain sequence. We do have the actors who are responsible for those events. So this is the model that we are defining as the normal workflow in our case. And then the types of anomalies that we are interested in this case are the following. Again, this is the normal flow that summarizes the previous diagram. And these are the types of anomalies. Majority of them are actually contextual anomalies. The first one is called the skip anomaly, in which one or more of the events actually are skipped and not executed. The rework anomaly states that one or more events might be re-executed when compared to the normal workflow. Early anomaly that talks about a certain event that was executed too early from its predefined sequence. Late anomalies are those who are executed too late according to the predefined sequence. Switch anomalies, as the name implies, we swap the order of two consecutive anomalies, two consecutive events. Attribute anomalies depicts a point anomaly when we have an error in the attribute value of a certain event. For example, here, the event that is called create vendor, it's supposed to be owned or performed by the central purchasing, but now we assigned it to the approval. And in this case, it will be considered a point anomaly as an error in the attribute value. And finally, the insert anomaly, which implies injecting a random event to the normal workflow in order to be discovered later. So we are in the phase of actually generating event logs because we need a lot of event logs to train our model. And also those event logs will be generated through simulation of the normal flow that we explained earlier. And also our model, our proposed model, which is an LSTM model, long short-term memory model, will be evaluated across real-world events obtained from the ERP system of one of our stakeholders of the project. To summarize our presentation, we actually introduce a structured yet extensive overview of the current research directions in anomaly detection, and I also get you a high-level view of the current work related to anomaly detection in supply chain domain related to my PhD study. So thank you so much for listening, and any questions will be welcomed.
Thank you very much for the interesting presentation. Let's see if there are questions. So if no one has question, I will tell few words. So I appreciate very much your paper presenting some of the anomaly detection techniques in literature. The paper provided a structured overview on the current research and the anomaly detection. Very complete. I like it. A real state of the art, and provide somehow a guide when selected the appropriate approach. Your case study related to anomaly detection in blockchain, supply chain area, and the deep learning approach, you started there, very nice analysis. I congratulate you and wish you good luck for your research in PhD.
Thank you so much, Doctor. Thank you so much, Doctor. And I also thank you, the organizers, for such an opportunity.
Thank you. Let's move further to the next paper. It's deep learning based classification on pancreatic adenocarcinoma for fine needle aspiration biopsy microscopic images. Paper presenter Abdel Hakim Azouz.
Hello, can you hear me?
Hello, you have the word.
Yeah, thank you very much.
Okay. Share.
Yeah. Do you see my my screen?
Yes, it's visible. Yes. Okay.
Okay. Thank you. Okay. So first of all, before I start, thank you for ICICT organization, because I enjoyed myself these 2 days attending all papers presentations. So my name is Abdelhakim Azouz. I'm a research engineer at Big Engineer School in Lille, in France, and my paper is about deep learning based classification of pancreatic adenocarcinoma from fine needle aspiration biopsy microscopic images. So this work is a collaboration between our big school of engineer, ISEN Junia, with the regional hospital of Lille, Sanofi, and Parasanté. So the summary of my presentation is as follows. I will start by introducing and talk about the objectives, also introducing the methods we use it, showing some results, the best one, and discussion, and finish with a conclusion and further perspective. So the pancreatic adenocarcinoma is the most common tumor presented in the pancreatic organ. It represents 90% of all the tumors. So because of its insidious placement here, The expert pathologist needs to apply a fine needle aspiration to take a sample and to analyze it using microscopic image analysis. So our help here and our work will be to develop a software based on artificial intelligence and especially deep learning to detect and classify this tumor, the adenocarcinoma tumors, on microscopic images. So our workflow starts as follow. So the expert pathologist start by applying a fine needle aspiration on a patient to get a sample. Then the sample is created into microscopic, looked into microscopic to create the whole slide image. After getting the whole slide image, so we apply a slide tiling program to create tiles at 96 times 96. Then we apply some pre-processing on these tiles to filter our results. Then we will train a CNN, a convolutional neural network based on our input tiles. Then we'll have a tile level classification. With this tile classification, we'll regroup them into squares at size 1000 times 1000 to guide and to help the pathologist to look onto the WSI. So our first method is to collect our dataset. So our dataset, we have unique dataset from our hospital in Lille here. It consists on 72 pancreatic whole slide images split into 50 tumoral whole slide and 22 non-tumoral. The average size of our WSI are 9,400 times 9,700, and they are all stained HES, which means hematoxylin, eosin, and saffron. On the left side, you have an example of a whole slide images we used. So the first thing here is we create tiles at 96 times 96. Here, an average number we created is 11,000. So it's a big number, and especially, for example, tile A and B doesn't contain any information, especially for the second part, which is the labelization part. So here we'll apply a pre-process, a filter program on based on the pixel of the tiles to reduce the number and to remove tiles that doesn't contain any information, just to keep, for example, here the C and D. And in average, we keep 41% of all the tiles. The second part of the method is to labelize the tiles. So our expert pathologist will labelize each tile into two classes. ADECA, which means tumoral tiles, and NT, which means non-tumoral tiles. Here is an example of a tile labeled. For example, here, the name of the slide, then the class, and then the crop. The crop, it's the coordinate X and Y and the image. So the third method here is we create our data set for our training phase. So from our 72 WSI images, we will use 68 of them to train and test our CNNs, our convolutional neural network, and we will keep 4 for the final validation comparison with the ground truth. So our data set consists on 21,652 tiles, split into 75% for the training and 25% for the validation phase. So the fourth part is we use a data augmentation method. So the data augmentation is a method that will increase our number of images artificially, of course. So here we use it, for example, 4 types of the functions for data augmentation. For example, a rotation, a horizontal flip, a vertical flip, and the Gaussian blur. Then we noticed that our size of data set increased. So we wanted to experiment 4 types of strategies. So the strategies are as follow. For example, strategy 1 and 2, we keep the same number of the data set as we started. It means 16,240. But for the networks and for the architectures, we on one time wanted to initialize the weights from scratch and the other time from ImageNet. And the same for strategy 3 and 4 for the weights, but not for the size of the data set. Here we use all the functions of our data augmentation to have this big number of tiles. So, and 5, the last part is the choice of the architecture, so of the deep learning architectures. Here we used 3 of them, VGG19, ResNet 50, and DenseNet 2001. And to adopt these architectures, we added we changed the 4 last layer into global average pooling, batch normalization, dropout, and finally a dense layer with 2 outputs, which are our classes, tumoral and non-tumoral. So here are the results of all our strategies and our models. So each model here have been trained 4 times following 4 strategies, and we based our choice on the metrics. The first one is the binary accuracy, and the second one is the confusion matrix. So here we noticed that, for example, VGG19 with strategy 3, DenseNet strategy 2 and 3 give good accuracies, and for the next step also. So here are some confusion matrices for the 3 architectures. For example, the VGG19 have good classification rate of the non-tumoral class with 99%. The DenseNet strategy 2 gave the best accuracy for the tumoral class classification with 99.9%, and the DenseNet strategy 3 is the average one, means a good classification rate with 96%. So following this, now we will compare the results of all our architectures with the ground truth. But for this presentation, I just wanted to show the best architecture based on the ratio. So here is, we asked our pathologist expert to labelize the 4 WSI we kept at first. So for example, we have 4 patients, A, B, C, and D, and our expert labelization labelize, tumoral tiles, for example, for patient A 103. So then we applied our software to detect the regions in the image. And for example, the true positive rate is, we just look at the true positive of our artificial intelligence software comparing to the expert labelization. And for example, for patient E, C, and D, we had good results, especially for A, for example, with 100%. Here is an example of the image and of our software results. So for example, image A is the labelization of our pathologists. The blue squares are the regions. And on B, the prediction of the VGG19 strategy 3 exactly. So here, for example, we can see that the blue squares matched with the pathologist ones, but unfortunately, we had a lot of false positive regions. So to conclude, we used a large data set provided from the regional hospital of Lille, from 72 different patients. We trained 3 different deep architecture, which are VGG19, ResNet 50, and DenseNet. For each architecture, we used 4 different strategies based on the number of dataset, the size of dataset, or the weights. And we noticed that the DenseNet architecture, especially strategy 3, gives the best accuracy, 96.5%, and the VGG19 gave the best accuracy for the final validation. So some further perspective, we want also to increase the number of dataset, to increase the number of tiles without using the data augmentation, maybe. Also to improve the potential of generalization of the experimented architectures, and test other models, deeper or not. It will depend if we increase the number of our datasets. So thank you very much for for your attention. Thanks for ICICT for this organization. Also, thanks to all our contributors for this work and paper. Thanks also to Dr. Oriane, pathologist, for the big number of tiles labelization. And thank you very much. Thanks for your attention, and I'm pleased to listen to any question. Thank you.
Thank you very much. Merci beaucoup. The presentation, very, very nice and interesting. Let's see if there are some questions.
Yeah.
So, if no, I can tell you that I consider very, very important your paper, your research here. You organize your own database, very nice. Together with the Hospital of Lille University. It's good that you want to expand this database, and so huge number of tiles they organize tiles labeled by pathologists. It's very important. Also to compare this different deep architecture is very nice, very nice. You compare them in terms of best accuracy, and the results are really very good, not promising, very good. If the database will be increased, I am sure you can have very, very good results. And it's a huge and important help for a pathologist. I consider they can use every year results in terms to give very, very fast diagnosis. So thank you very much, Hakim. Very nice.
Yeah, thank you. Thank you very much. Have a good day. Thank
you. Let's move to the next paper. Leukemia subtype classification by using machine learning techniques on gene expression. Presenter Hassan Badem. Are you here?
I'm here. I'm Ebru Simse.
Ebru, okay.
Due to some
You may
reason, Dr. Hassan Badem is not able to present the paper. As a corresponding author, I am going to present the paper.
Okay. Please share.
Can you see? Can you see my presentation?
Yes, very good.
Okay. You can have something. All right. Hello, everyone. Welcome to 6th International Congress on Information and Communication Technology. First of all, I want to introduce myself. I'm a very student at Kahramanmaraş Türkçe University, Turkey. I research on bioinformatics, machine learning, and deep learning. I will present the study entitled Leukemia Subtype Classification by Using Machine Learning Techniques on Gene Expression. The content of our study is presented. Firstly, I will introduce the background of the study where the data is based on. Then I will mention about DNA macroarray, that is the method to obtain data. Then I will define the holding problem, that is leukemia subtype classification. After that, I present the proposed method. I will finish the presentation with the obtained results and conclusions. Since cancer can be caused from many different reasons, it is one of the diseases that has been investigated for years. It's extremely important to accurately predict the type of cancer in order to be able to apply the correct treatment. Gene expression. All events in the body are directed by the DNA in the cell nucleus. For this, messenger RNA is synthesized from the relevant code region in the DNA that we call transcription. Then synthesized messenger RNA leaves the nucleus and goes to the ribosome. In the ribosome, the messenger RNA code is read by the transfer RNA that we call translation, and the amino acids corresponding to the code are determined. The protein is produced by combining the amino acids in determined sequence. To produce functional protein pulses the task determined by the gene. Thus, the gene is expressed. With the DNA macroarray technology, the gene expression array can be measured. How the gene works. After protein production, it regulates many functions in the body. So from gene to protein to its function, the information in the gene is expressed. All molecules of the body are formed and all functions of the molecules are regulated. Hereditary errors. Due to any reason, errors may occur in the DNA sequence, so the course of the relevant gene region may change. This change may occur due to genetic inheritance from parents or by latent mutation. When the gene region whose code change is active, RNA is synthesized with incorrect code. Erroneous RNA synthesis causes erroneous amino acid sequencing and erroneous protein production. Incorrectly produced protein either fails to fulfill its task or performs the unsuspected task. Therefore, the cause of hereditary recession is the transfer of the wrong code from gene to protein. If the protein produced via protein synthesis fulfills its task, it means that the related gene actively works. Hence, by measuring gene expression level, the activity of related gene sequence can be determined. DNA microarray technology. By using DNA microarray method, gene expression measurements can be obtained in order to monitor gene-related diseases. This method uses a microchip with a non-single stranded DNA chain. For this method, first the mRNA is separated from the patient cell. Next, complementary DNA, which is complementary to messenger RNA, is synthesized by reverse expression that is similar to messenger RNA expression from DNA. Complementary DNA are dyed with fluorescence dye and applied to the microchip. Fluorescence is an indicator of complementary DNA binding to single-stranded DNA chain in microchip. According to the binding amount of fluorescent labeled complementary DNA to single-stranded DNA in the microchip, fluorescent radiation occurs. Numerical values are obtained with these fluorescent radiation measurements. If the binding is high, the gene region is active, and the amount of radiation indicates this. Binding means the gene is expressive. The data that is gained from DNA microarray method is stored in the database and used for further analysis. Leukemia. One of the hereditary diseases is leukemia. In leukemia, white blood cells are excessively proliferated. Cancer is considered to be uncontrolled overgrowth of cells, so leukemia is also known as blood cancer or bone marrow cancer. You can see white blood cells can be basophil, neutrophil, eosinophil, monocytes, lymphocytes, B lymphocytes, T lymphocytes, neutrophil cells. Why blood is being produced? First, the blood stem cells are produced in bone marrow. Then these blood stem cells transform into lymphoid cells and myeloid stem cells. Lymphoid stem cells and also myeloid stem cells are transformed into leukocytes called white blood cells. Although leukocytes have varieties in themselves, their main task is the immunity. Leukemia is the uncontrolled and excessive proliferation of these cells. Excessively proliferated leukocytes inhibit the functioning of healthy leukocytes, responsible for immunity. The immune system becomes inadequate and other required cells production is reduced. Leukemia is divided into two subtypes as acute lymphoblastic leukemia and acute myeloblastic leukemia, depending on the stem cells it originates from. By expressing the information in the gene, all these different processes are named. Different chemotherapy drugs are applied as treatment for acute lymphoblastic leukemia and for acute myeloblastic leukemia. Incorrect drug used in chemotherapy will not cure leukemia. Since time is important, it can be late for the treatment. Wolf et al. Has been used a general systematic approach to predict the class of leukemia disease subtype by analyzing the obtained data. By using machine learning algorithms, a fast and meaningful result can be drawn from the available data, and errors may occur in the diagnosis of the disease can be prevented. The method overview is like this. The dataset has been first examined, and pre-processing steps were carried out. When the dataset was ready to process, the system trained with trained data, then model developed. Model was tested with testing data. According to those, model was evaluated. If you look at the dataset used in the study was prepared by Golub et al. And presented in the Kaggle dataset repository with the title Gene Expression Dataset. The shared dataset contains a total of 72 patient records. The samples were taken from the bone marrow of 62 patients and peripheral blood of 10 patients. The features of the datasets are 7,150 29 gene sections. Since the dataset was shared as separate parts, as training and test data, it was used in its published form for analysis. Shared training dataset consists of 38 patient records. All 38 records in the shared trained data were also taken from bone marrow. Shared test dataset consists of 34 patient records. 24 of the shared test data are from bone marrow and the remaining 10 are from peripheral blood centers. Then whole dataset was merged and analyzed. Merged dataset consists of 72 patient records. Machine learning allows to find patterns in the data and decisions based on that. Classification is a supervised learning technique of machine learning. Patterns are found by training the system with a dataset, whose classes are determined by an expert opinion. Thus, a decision mechanism that can be used in the new data is created. Performance of the classification method is evaluated with tenfold cross-validation method. In tenfold cross-validation method, trained dataset is divided into 10 parts. Only one part is used for testing and the remaining 9 parts are used for training. This process is repeated in order to use every part as a test and training. K-nearest neighbors. In the KNN algorithm, the distance between the searched data and the other data are calculated, and the nearest neighbors are found according to the distances. If the most of the nearest neighbors are in a class, the searched data is thought to be belonging to that class. Linear discriminant. LD algorithm examines the distribution in the dataset, finds the difference from the mean value, forms the discrimination methods, and determines the classes accordingly. Support vector machine. SVM algorithm examines the dataset distribution. Classification is done by establishing a linear or nonlinear decision mechanism according to the distribution. The aim is to calculate the ideal decision line that should be the maximum distance margin from the data. Ensemble classifier. EC combines decisions using multiple learning algorithms together rather than learning with a single algorithm, and classifies the searched data by looking at the mean. Sorting experimental results. MATLAB R2018A software was used on system with 253 GHz Intel Core i5 and 460 processor and 3 GB RAM memory. First, the shared trained data was trained and then shared test data was tested with developed model. After that, the merged data is retrained and main model was developed. The accuracy rates of classifier results are presented in table B, and the confusion matrices of the classifiers are presented in table C. In order to be fair in comparison, firstly, only the shared training data was used with 10 times cross-validation during the training process. Nevertheless, the shared test data was tested with the developed model. Then the merged data retrained with 10 times cross-validation. The shared test data was also tested with the developed mean model. If we look at the table 1, shared trained data results show that LD and SVM have the highest accuracy rate with 94.7%. Shared test data results show that LD classification model provided the highest accuracy with the rate of 91.1%. Considering the difference, the accuracy rates of the LD for shared train and shared test, it may be thought that the situation is due to the interpretation error of dataset. The merged dataset results, it is seen that SVM has the highest accuracy rate with 98.6%. So it is considered that SVM model has a higher accurate prediction rate with the new training data. It is observed that new training data formed by merging, shared test and training data accuracy rates were increased. From this point, it can be concluded that if the machine learning algorithm was trained with more data, it learns more, so it makes more successful prediction. If confusion matrices are examined in the table 2, in shared data for 38 records, LD and SVM models gave 27 acute lymphoblastic leukemia and 9 acute myelodysplastic leukemia for the prediction and 2 false prediction. While KNN and EC gave 27 acute lymphoblastic leukemia and 8 acute myeloblastic leukemia for a prediction and 3 false prediction. In merged data for 72 records, LD model has 46 acute lymphoblastic leukemia, 24 acute myeloblastic leukemia through prediction, and 2 false prediction. SVM model has 47 acute lymphoblastic leukemia, 24 acute myeloblastic leukemia through prediction, and 1 false prediction. KNN model has 45 acute lymphoblastic leukemia, 18 acute myeloblastic leukemia through prediction, and 9 false prediction. And EC model has 45 acute lymphoblastic leukemia, 21 acute myeloblastic leukemia through prediction, and 6 false prediction. The obtained experimental results show that when the dataset was trained as shared, the algorithm has a higher accurate prediction rate on the shared test data. When the shared test data and shared training data combined and formed into a training dataset, it is observed that the SVM model has a higher accurate prediction rate. According to the obtained results, these models can be used to diagnose leukemia disease subtype. Considering the importance of time in cancer diagnosis and correct treatment, machine learning can be a fast and accurate tool for leukemia subtype diagnosis. Thank you for listening. Is there any question?
Yes, thank you very much for the presentation. A really interesting one. If there are questions, please. So some remarks from my side. It is very nice. Also, you are interested to help medical doctors in early diagnosis and correct treatment in this important disease, leukemia. You use machine learning techniques, and I saw you introduce different algorithms and you compare them. I saw also a nice data set that you also organize, very good also from this side. And results were compared to see accuracy for different methods. It is also a nice research. I congratulate you. And you will continue to improve your data set. I can tell you that it's good to collect more data sets or to use data sets from different web pages in GitHub and so on, or from other hospitals if they offer for free, because I know it's very costly to obtain. I saw you use MATLAB. It's also nice, and all these techniques will help medical doctors for sure. So artificial intelligence is going very fast to help medicine. That is true. Thank you very much once again for the presentation.
Thank you.
And
I wish you
success
have a nice day.
in your next research. So the next paper will be contextual recommendation using NLP in digital marketing. Paper presenter, it's Yashwari Bahirat. If he's here.
Yes,
Yes.
I'm here. Okay, so I'll start off. Thank you.
Yes.
Thank you so much. Firstly, I would like to thank organizers, the panel members, and also the reviewers for taking out the time, selecting my paper, and also like providing me this opportunity. Cool. After this, I'll start presenting my work. So if like I can see the still the last presentation being shared. So should I just stop it?
Stop the presentation.
Yes. Okay.
Ebru, please stop the presentation. Yes.
Okay, thank you. I'll start with my presentation. Okay, so yes, I'm Aishwarya Bhahirat from India. I work at a company called as MIQ Digital. And what we have done as a part of the project which we implemented is built out a generalized recommender system that utilizes the data which we get in the field of digital marketing to target or to reach out more relevant audiences. Now, what I'll do is I have divided the presentation into 5 sections. First is introduction. Next one is telling about the problem statement. Next, third one is methodology, then result and conclusion. So what we do is we operate in the field of programmatic advertising. For those who don't know what programmatic advertising is, it's basically like all the display ads or online ads you see. Basically, whatever advertisers, whatever you're browsing based on what your previous history has been, the transactions which you have done. So all these kind of things kind of make your peer profile. And in that way, you are being targeted constantly with maybe certain advertisers ads or even like non-profit organizations, government organizations, all these things to reach out different kind of users. Now, the bigger problem statement which we are trying to address here is whenever any organization or anyone is doing such work, they're continuously accessing your privacy. They're continuously accessing your previous data, thereby like there are bounds which are being exceeded. They are not respecting your privacy. Your location data is being continuously accessed, or all of these things. So in last couple of years, to counter this problem, a lot of government agencies like GDPR and CCPA, they have come up, which kind of tells two things. One is your personal information won't be stored. You cannot use any of these data to model anything, like to have, let's say, if you are going to maybe some stores, or if you're buying certain kind of drugs or medicines, then what disease you are suffering from. So these kind of modeling or just simple modeling, these or any kind of predictive modeling is not going to be used. You cannot store their data as well. So what it does is it kind of puts for the companies like us, and also the bigger players who are in the market like Google and AppNexus, Facebook. What it does is it kind of sets some regulation that what you will do with the data will be limited. So what we wanted to come up was an innovative solution which doesn't take any user level information, but what it takes is the content to find some similarity between the content which is being browsed by some people. And we are not going to use any user level data here. And to just try to I will try to clarify here. So when we are trying to reach out any user, we generally reach them through their like whatever site domain you visit. We are not trying to access your history, whatever site domain you visit or these kind of things. So we'll have a generalized targeting. So on that, what we have done is we have implemented, and to just have some more clarification, the data size which we get is around like for just one day is around 3 to 4 TB of data. So it's huge. It's like to run any machine learning or deep learning model on 4 TB of data, it's very time consuming. So we have all of these, whatever the architecture which have been shown here has been implemented in a big data environment on PySpark. So what we do is, I'll quote one of the quotes by an engineer, John Rupert Firth. He said that you can identify a word by the company it keeps. Basically, what he's trying to say is usually similar contextual words would appear close to each other. Like I'm speaking in English right now, my choice of words would be such that the words which are related would be used nearby to each other. So we extend that idea to the URL and the domains which you are browsing. So basically what we are saying is the keywords which will be present in URL are contextually related to each other. So if I'm browsing Dell, then XPS is also related to each other. They would be used in similar context. Similarly, for site domains, whatever you are browsing,
No sound from my
sorry.
side. Now it's okay. Sound.
Is it okay? Okay. So I'll just repeat. What we are trying to achieve here is the keywords which are appearing in the URL and in the context as well, they will have similar keywords next to each other, which would define the context. Similarly, what you are browsing, the sequence of your browsing would define the context. Let's say you're trying to book some holiday, you will first go to an airline, or then after that you'll search for hotel. So they do have some context behind that. So similar kind of domains would appear in the same context. So this model is just, then what we do is we create these sequences of keywords and site domains of your browsing. And there is nowhere we are storing your user ID. It's just a sequence. There is no user identifier. Then we run a shallow deep learning model on this, which is word2vec. We implemented word2vec because we went through multiple algorithm, that is continuous bag of words, word2vec, ngram language model. But we found out that based on the papers which have been cited earlier, word2vec works very well in a big data environment. And considering the size of data of around 4 TB, that's just for one day, word2vec was a easy winner for us. And what we did was we implemented this word2vec, and the input is the sequence. The output which we get from this model is vectors. For each word, a size of 300, we define the size ourselves. And it's usually from the paper only, which was presented on word2vec. They said that a 300 to 500 vector size is good. So we played around with that and we went ahead with 300. And for each keywords or all the words in the corpus, we get a vector of dimension 300. Now, when we give certain words, like let's say here, I have provided Dell, what it gives me is the set of similar keywords who based on the cosine similarity of these vectors. Now consider this is the first level of output which we get for some keywords for any particular brand, for whom I'm going to be advertising. I run that brand's name and get related keywords. And after that, what we do is, first thing is we define similarity. Then we define, because it's like in ad tech or in digital advertising, whenever you see an ad, within 0.3 microseconds, there is a bid happening on the back end, and the company or the organization who bids highest wins that. So what we want is, when we are trying to reach a relevant user, we want to bid higher, because I know that he will buy my product, or he's my preferred user. So I want to bid higher. So let's say I'm running an ad campaign for Dell. So I want to reach user who is searching for XPS, Lenovo, Alienware, because these are contextually related, which our model gave out. So we find the bid price for them and also how many past users we have reached. And these two metrics, like bid price and scale, is available to us from the past data. Based on these, we create a linear weighted combination known as bid modifier using these three features. First of all, we standardize and then min-max normalize to create bid modifiers, so that we can give more importance to the keywords which are related. And so this is the complete architecture. And what we have observed is, moving on to the results, what we have observed is, so there are two terminologies I would like to define here. First is CVR, which is conversion rate, and CPA. Conversion rate just tells you that if I have served 1,000 ads, how many of them actually purchased my product. And CPA tells you like how much did you have to spend to get like one conversion. So in this case, we did observe that for the recommendations which we made, the CVR was 3x higher, and also the CPA was 3.5x lower, which is both a good sign that we are performing 3x better, and also we are 3.5x more cost efficient. And one more thing which I would like to cover is the second model which we have told here is what we compared against is just overlap based model. Like I am browsing this website and I'm also browsing that website. So if I convert from this, so the next one would be also more useful. So just on the basis of user overlap, which has been made like sort of illegal as well as has been prohibited. If you are being found, there are heavy fines on the organizations. So yes, moving on to the conclusion part in the interest of time, I would say that each day, considering the environment in which we work, petabytes of data is generated. The problem statement remains the same: to reach the relevant users at an optimal cost. Then modeling user for each advertiser every day is a bit inefficient. And now, considering the laws, it has been restricted in many countries. So what we propose is our approach, which uses neural network to learn association between the keywords and domains, and does not use any of the user attributes whatsoever. And then what it learns is the keywords of your brand and the site domain of your brand. What are the similar site domain and keywords which will be browsed by your audience, and then we reach them there. And the efficiency lies here that each day we don't need to train it each day for all the advertiser. We just train it once. This can be used across geographies, because Dell would remain Dell in Canada as well as in India. It would remain same. Once trained this model, this can be used for multiple clients, and we have seen a very good performance for multiple clients which we have tested. We have seen an increase in performance and reduction in overall cost. Yes, and I would like to wind up my presentation with this. Any questions are definitely welcome.
Thank you very much. Let's see if there are questions. So your presentation is also very interesting in the area of digital marketing.
Yes.
We utilize online platforms and digital technologies for marketing of products and services. I saw you use that model with the neural network, and also you compare that CVR and CPA for final conversion point. Yes, very, very interesting. And I'm sure that there are some companies that are interested in your product and to do an analyze and to receive some conclusion to increase their performances, isn't it? I'm sure for this everywhere in the world. So a really nice presentation, and you also have a huge work back, and programming also I saw here. And as you said very well, that some other methodologies are very time consuming, and your choice is the best one. Congratulations once again, and good success for your work.
Yes, thank you so much. Means a lot.
Thank you. Let's move to the last presentation. And I don't know if the first paper is here with us. If no, we will move to the last one, an empirical evaluation of machine learning methods for the insurance industry. Yes, it's here, the presenter, Olaf Zukunft.
Yes. Yeah, that's right. Olaf Zukunft, that's my name. Hello and a warm welcome. After we heard quite a lot about the health industry, COVID and cancer, we moved on to marketing. And finally, I will tell you a little bit about the exciting domain of the insurance industry. So my talk is structured into 5 chapters. First, I will tell you a little bit about our domain. Then I will introduce you to the data set we have used in our experiments. I will give you a short overview of the different machine learning algorithms, although Carlo and Ebra have already shown you some of them. The most interesting part is the evaluation of the algorithms which we have performed. I will give you a short overview of the experiments and of course of the results, and I will then conclude and give you some impressions of our future work. So what are we doing? Well, we are working with some problems which occur in the insurance industry. You know, insurance industry is where you give a lot of money to some people and you get a piece of paper in return. This piece of paper tells you that they will pay if you have some damage. And this is what we are considering. We have the processing of claims in our domain. So as you can see here, what happens when, for example, some water damage happens in your house. A claim is created first because, for example, water is running all through your house and you will call your insurer and say, well, something happened. I want my money. What happens then is that some data is recorded because the insurer will ask you some questions. For example, what kind of damage is it exactly and where does it occur and how long ago did it occur? It will also give you something about the insurance information and so on. And as you can see, this seems to be some kind of interesting data which we can use for machine learning. In our part, we have the machine learning prediction, and we perform 2 tasks based on the recorded data. The first one is the question, should an expert be sent to the damage site? So the insurance may choose to send you an expert which takes a look at the damage, or they may choose not to send an expert and just pay the bill. The second thing insurance typically do as soon as a claim is created is that they predict the claim reserve, which is a regression task considered from the machine learning prediction portfolio. So when you take a look at this, you will find quite a lot of related work on machine learning in the insurance industry. However, most existing research focuses on fraud detection, which is of course a big issue in the insurance industry. They also handle error prevention in claim processing, the underwriting process, even chatbots for customer support. But we have not found any previous work which handles the claim processing using machine learning. So what have we done? We contacted some insurance companies and we got a real world data set with more than 300,000 insurance claims related to water damage. This data set includes 33 different features. For example, which kind of water damage is it? Which kind of object is affected? Is it a big house? Is it a small house? Is it an apartment? And some temporal information, for example, when was a claim created, when did the damage happen, and so on. Furthermore, we were lucky because our real-world dataset contained two labels. The first label is the question, is sending an expert to the damage site useful? And the dataset was labeled with this. And the second label is, how much compensation do we estimate based on this first claim processing? We used the dataset and performed some pre-processing, for example, standardization and one-hot encoding of the numerical values. Afterwards, we considered which algorithms may we use to perform some machine learning on this claim processing task. As Carlo has already introduced us into naive Bayes, it's the good algorithm useful for the classification, for example, for the sending of an expert to a damage site or not sending an expert. The second one was shortly before introduced by EBRA. It's the K nearest neighbors. As you can see here, the different colors means different classes. And we have the two classes of sending an expert or not sending an expert. Then we have regression. Regression is not only for classification, but we can also use it for the regression task we are currently performing. The fourth algorithm we are considering are decision trees. We have also already seen this in this session. Then the support vector machine, which is the computational most expensive one when you consider these different algorithms. And finally, the star of the season, the so-called neural networks, deep learning, the method of choice, or isn't it the method of choice? We will take a look at this in a few minutes. So what have we done? We have taken our data set and the different algorithms I just introduced to you, and we have performed the experiments. First experiment was to answer the question whether we want to send an expert to the damage site. Regarding the machine learning domain, this is, of course, a binary classification task. And we identified the methods naive Bayes, the K nearest neighbor, the logistic regression, two different kinds of decision trees, namely CART and C45, the support vector machine, and finally, neural networks. The evaluation, as we have already seen, can be done based on the confusion matrix and different scores. Accuracy was used by all the other speakers in this session, but as you can see, apart from accuracy, we can also use precision, recall, and the F1 score. And our domain expert told us that in this case, precision is the most important one, because it is worse to send an expert when not needed than vice versa. This second question we want to answer with the machine learning algorithms is whether we want to, how much the initial claim reserve should be. So as soon as a claim is created, every insurance company wants to predict the initial claim reserve and put that money aside in order to settle the claim. From the machine learning perspective, this is a regression task. And the methods we considered are linear regression, the CART, the decision tree, the support vector machine, and again, neural networks. Here, the evaluation is based on the mean absolute error. So we want to know how much error is there based on the labeled data set we have used. So when you take a look at this table, you will see the results for the different algorithms on the classification task, whether to send an expert to the damage site or not. You can see that the different models perform quite differently. But as I said, precision has been defined as the most important one by our domain experts. And for our site, the precision with the neural networks is the best. So the precision is 80%. The accuracy here is 92, which is also among the best. And the F1 value is only 0.14 because the recall is, of course, very low. For the second question, the prediction of the claim reserve, which is a regression task, we have a baseline. The initial reserve, which you can see above, is 2,285 euros. This is the number which was estimated by the human employees at the insurance company. All the different algorithms we have used do perform almost better than the existing human employees at the insurance company, especially the support vector machine and the neural network seems to be the best candidates. So again, the neural network is the best one. So when we summarize the results we have achieved in this domain, is that we found out that neural networks perform the best on both tasks. They outperform the human experts, the regression task. So we want to take a closer look at the neural network we deployed. We had a 4 layers neural network with 32, 32, 16, and of course 1 neuron at the end for the binary classification, which means that we had approximately 9,000 trainable parameters. So what is the conclusion of this talk? Well, machine learning is a promising tool for the insurance industry. And this is not based on some artificial data set, but a real world data set, which we got access to from some insurance company. Neural networks outperform the humans on the reserve prediction based on the data set we acquired. And for future work, we want to do 3 things. We want to collect more data, which is of course always a good idea in the domain of machine learning. Then we want to better structure our data and perform some more and better feature engineering. And finally, we would try to open source a data set based on what we got, because currently this is under a non-disclosure agreement. Okay, thank you very much for your attention. And I just want to mention that this work was supported by the European Commission. And I would be happy to answer any questions.
Thank you very much for the interesting presentation. Let's see if there are questions. It seems no, but some of my comments. It is true, we have many different methodologies for different domains in this session. So you presented an interesting methodology using machine learning techniques to identify, to handling insurance claims related to water damage. You compare also the performance of different machine learning models, and you observe that the neural network is performing the best. It seems neural network and for other papers, deep learning, it's a good tool. So I observe also the claim reserve prediction made using neural network. So you organize a data set, you want also to collect more. You are on the best way. And once again, congratulations for your work. Also, it was supported by an important project in your university or institute in Hamburg. And I'm sure you will continue with another project, because the field it's very interesting. And in this direction, I'm sure many such companies for insurance will be interested for your results and your work. Thank you very much. And congratulations for the presentation once again. Let's see if the first paper, for the first paper, the presenter is here for applicability of AutoML. No, it seems no. Yes. So
no, I don't think so.
Pardon?
No, I don't think she's here.
Yes, maybe she cannot join us. It is true. I congratulate you all for coming with your nice work in this important event, and hope to see you again in the next session, in the next edition of the conference. Please develop your work and try to apply for project, because project means money, more papers also in conference and in journals. Thank you once again. Maybe, I don't know if the organizer, my co-moderator, is in my opinion, to have all people here with their camera open.
Yeah, just some quick closing remarks before that just then.
Yes.
Yeah, we just want to thank all our authors for their excellent presentation in this session, and all our participants for being part of the International Congress. All the presenters will be getting their digital certificates through the mail within 2 working days. Further, all papers have already been forwarded to the Springer, and the publication will be live within 4 to 6 months. I'd also like to thank our session chair, Valentina Emilia Ballas, for chairing the session. A token of appreciation to the chair on behalf of Team ICICT 2021 Global Research Foundation. Thank you, Madam.
Thank you.
And as she said, yeah, if we could all just quickly turn on our cameras for a quick screen, please.
Yes. Congratulations to all of you, and hope to meet you again in the next edition or in other conferences in Europe or everywhere in the world. Thank you.
I've got it all. All right, thank you. Have a good day to you all.
Thanks you, everyone.
Have a nice weekend. Goodbye.
Thanks all.
Bye.
Thank you, everyone. Thank you very much.